Hello everyone, this is Chris and today this video is basically for the mock test. I will cover several questions and basically it's question 3 part 2 and question 6. Okay, question 3, you have a coin with 3 outcomes, 1, 2, 3 with probability 1 over 3 for each. So what is the expected number of throws until you get 3? So in this question, someone asked me why we have an equation like this. We have the equation x equals to 1 over 3 times 1 plus 2 over 3 times x plus 1. Here, the x is the expected number of throws is what we want. This is what this question asks. So basically this equation comes from here. So the expected number is x. So x, and then when you calculate the expected number, you just sum up the probabilities and the conditions and under a certain condition the number of throws you have. So you have a condition, then you know the number of throws, then you multiply by the probability of this condition, you sum them up, then you get the expected number of throws. So here and here actually we have two conditions. So we have p1 times x1 plus p2 times x2, and the trick here is using for the x2 we can use the expected value of x2 to substitute, because x2 itself isn't constant. So if it is constant, so you can use the expected value of x2. For this question, we have two conditions. The first is in the first throw you get 3. The second is you get 1 or 2. When you get 3, then the probability here is 1 over 3. And here, what you drew once, so the number is 1. So for the first part of this equation is the probability times the number of throws here. And for the second condition, the probability is obviously 2 over 3. And the here the expected number of get 3 is x plus 1. Why? Because this game itself is an independent game. This indicates that the outcome of the last throw doesn't have anything to do with the game, with the next part of the game. So once you get 1 or 2 in the throw, the game restarts. So the expected number of a game you get 3 is always x, but here in the first you failed once, so you have to count this once in, so it's gonna be x plus 1. It means under this condition, under the condition of you get 1 or 2 in your first throw, the expected number of throws you're gonna get x, you're gonna get 3 is x plus the one you did before. So the probability here is 2 over 3, then the expected, the ex2 is x plus 1. So this is why we have this equation. And if you solve this equation, you're gonna get x equals 3. This means the expected number of the throws is 3, we'll get 3. Okay, this is the first part. The second part is question 6. Okay, for the question 6 is a simulation question. The R code here is not that hard. This is all the R code you can get for this question. And some of you asked me that why here is a to the power of 1 over 4. So then I will explain it. So we can see for every distribution, like we can see the cumulative probability here, the cumulative probability has a 1-to-1 relationship to the random number entered in this distribution. So this means if you can tell me the cumulative probability, then I can tell you what random number it is. So in this simulation, actually first here we use RANIF, is we get the random numbers from a uniform distribution between 0 and 1. So the cumulative probability, it also fall within 0 and 1. So in this case, we can use a uniform distribution from 0 to 1 to simulate the cumulative distribution. The cumulative probability here. So it's like you randomly get a cumulative probability, and under a certain relationship, you get the you tell me the cumulative probability, I can get you the random number. So once you simulate the cumulative probability, you can use the function a to the power of 1 over 4. It's just the inverse function of this cumulative function. So the y here is the cumulative probability. You tell me the cumulative probability, and if I calculate it as y to the power of 1 over 4, then I get x, then I get the random numbers. That's how we simulate random numbers from a certain distribution. And this is what we want from this question. And the only hard part here is the apply command. So use apply command, you have to always remember 3 components. The first is where to apply. The second is you want to apply in rows or you want to apply in columns. And then the last is what function you want to apply. For a central limit theorem, so you want to apply the mean function to each simulation. So each simulation is each row here. So I apply and each rows, and each row stands for one simulation. Then I simulate 1,000 times. It's what the question asks. So you apply it with the main function. Then if you run this code, you can get a kind of like a normal distribution, and the shape of this curve is gonna be a bell curve here. So basically for this question, you have to know y here is a to the power of 1 over 4, because you simulate the cumulative probability first, then through this cumulative probability you get the random number, and then it's the apply function. So if you know this, you're gonna be okay, feel comfortable with this kind of question. That's all. Thank you.